I've noticed lately there have been several videos about coin tossing in scientific YouTube channels. There was one from Vertasium, one from Vsauce, and several more from Numberphile. All great channels, by the way, and if you don't know them, you should probably go ahead and check them out. I really think you'd like them. Well, in those videos, they've covered different aspects of coin tossing, regarding the physics of a coin toss, how much the process of coin tossing is actually random, and even some psychology aspects. And I really felt like they've missed something very interesting when discussing biased coins. That is, coins that have a greater probability of producing one end of the coin than the other. Now, what they've missed is how do you take a biased coin and use it to produce a fair coin toss, a fair game of coin tossing that will produce the same kind of probability for heads and for tails. Well, the idea is in fact very simple, and I would like to show it to you.
Okay, so this is called the von Neumann's coin flipping algorithm, and the idea is fairly simple. So let's take an example, and we'll say that we have a biased coin that produces heads with a probability of 0.6 and tails with a probability of 0.4. Now what we'll do is we'll toss the coin twice, and this will produce 4 results. One will be heads and then heads, the other will be tails and then tails. After that we'll have heads and then tails, and tails and then heads. Now respectively, the probability of each of these are heads and then heads. This is 0.6, 0.6, this produces 0.36, and 0.4 times 0.4, this produces 0.16, 0.6 times 0.4, this produces 0.24, and 0.4 times 0.6, this produces again 0.24. You may already see where this is going. So what we'll do is we'll assign a result for each one of our possibilities. Now we'll just redo with the first two. These produces respectively 0.36 and 0.16, but the last two produces the same probability. So we'll call this one heads, and we'll call this one tails. And what we have right now is a game that we're playing using a biased coin that produces heads 0.6 and tails with a probability of 0.4, and it produces two results that have the same probability no matter how biased the coin is. It could be a simple 0.51 probability of heads, or it could be a 0.2. The difference is how much of the time we'll have to redo it, but the fact remains that the valid options always have the same probability, and this is due to the commutative property of the multiplication operation. So that's it. Hope you enjoyed the video. Like it and share it maybe.